Hi, my dear subscribers. I am Lakshmi Ponnada. In today's class, we are going to learn about the Donnan membrane equilibrium. Donnan membrane equilibrium is an electrical property of colloids. This Donnan membrane equilibrium is used to enhance the absorption of drugs such as sodium CMC, sodium carboxymethyl cellulose, and sodium salicylate. For explaining this Donnan membrane equilibrium, we have to take a solution containing electrolyte, means NaCl solution is placed on one side of the semi-permeable membrane and other side solution containing negatively charged colloid together with its counter ion. Counter ion means here we are negatively charged colloid, we are taking positive ions such as Na plus ions. Okay, here we are taking a semi-permeable membrane at initial state. At initial state, this is a semi-permeable membrane. This is the outside of the solution represented by O, and inside of the solution represented by symbol I. In both sides, we have to maintain equal volumes. We have to maintain equal volumes. Outside of the solution, we are taking NaCl solution, means in outside there are Na plus ions and Cl minus ions. Whereas inside of the solution, we are taking a negatively charged colloid. That colloid, negatively charged colloid, represented by symbol R minus, and along with its counter ions, that is positive ions, Na plus ions. Okay, this Na plus and Cl minus ions will move freely across the semi-permeable membrane, whereas this R minus colloidal ions, colloidal ions, they do not diffuse through the semi-permeable membrane. Okay, next condition is at equilibrium. Semi-permeable membrane, outside, inside, outside of the solution containing Na plus and Cl minus ions, whereas inside of the solution negatively charged colloid along with its counter ion Na plus ions, where Cl minus ions will move across the semi-permeable membrane and passes inside at equilibrium condition. At this condition, we have to apply electrical neutrality. Electrical neutrality means positive and negative charges on either side are balanced. Positive and negative charges on either side of the semi-permeable membrane are balanced. For this we have to derive an equation. First we have to write outside of the solution. Outside positive and negative charges are balanced. Outside, that is Na plus, concentration of Na plus ions is equals to concentration of Cl minus ions. This is the equation 1. Outside we have to represent by O, and inside of the solution, positive neutrality, apply electrical neutrality means positive and negative charges are balanced. Here the positive charge Na plus ions, concentration inside I is equals to negatively charged colloid inside R minus plus Cl minus inside. This is the equation 2. Here we have to mention about escaping tendencies. Escaping tendencies of electrolytes. Here, the escaping tendency of electrolytes means the concentration of electrolytes on both sides of the membrane are same. Concentration of electrolytes on both sides of the membrane are same. For this, we have to write concentration of electrolytes. Electrolytes means Na plus and Cl minus ions. Both sides are equal. Concentration of Na plus outside and concentration of Cl minus outside is equals to Na plus concentration inside and Cl minus concentration inside. Okay, this is the equation 3. Substitute first and second equations in third equation. Na plus, in the place of Na plus outside, we have to write Cl minus, concentration of Cl minus outside. Concentration of Cl minus outside into concentration of Cl minus outside is equals to inside. Concentration of Na plus ion concentration inside, in the place of this Na plus we have to write concentration of R minus inside plus concentration of Cl minus inside. Into Cl minus inside concentration. This concentration of Cl minus outside, concentration of Cl minus outside, undergoes multiplication, we can get concentration of Cl minus outside square. And we have to multiply with concentration of Cl minus. Here, concentration of R minus inside into concentration of Cl minus inside plus chloride ion concentration inside, undergoes multiplication, it becomes square plus Cl concentration Cl minus ion square inside. Cl minus outside is equals to the above equation. This equation we can rewrite like this in a most simplified form for deriving purpose. 1 plus R minus inside divided by chloride ions inside into chloride ions, concentration of chloride ions inside square. Okay, we can then chloride ions inside square, it will move into this left hand side. Inside square, chloride ions outside square, chloride ions inside square is equals to 1 plus R minus counter ion inside divided by chloride ions, concentration of chloride ions inside. And this square of chloride ions out, concentration of chloride ions outside square divided by concentration of chloride ions inside square, when it's moved to the right hand side, it becomes square root. Chloride ions outside square divided by chloride ions inside is equals to square root of 1 plus R minus concentration inside divided by chloride ion concentration inside. Okay, this is the final expression for Donnan membrane equilibrium. Okay, and it is useful for this Donnan final expression of Donnan membrane equilibrium is used for the calculation of ratio of concentration of diffusible anions outside and inside the membrane at equilibrium. Thank you. Please like, share and subscribe my channel.